Hello, grade 12s. Question 6 on the pre-June exam mathematics. It's a very, very interesting and something. This one, watch out, watch out. I think examiners here, they are showing their cards. Something like this might come in your final exam. So you look at the function f of x equals to 1 over 4 x squared, which is what it's been given to us here. F of x equals to 1 over 4 x squared, which is called a quadratic function. Now, what they are doing next to our function, they are restricting our domain. They are saying, look at a function f of x whereby the values of x are positive. Consider only this function where the values of f of x are positive. But for your understanding's sake, listen carefully. I'm going to remove the domain a bit. I'm going to remove, the restriction a bit. So I'm going to leave the restriction little bit so that you are going to follow what I'm going to do, so that you obtain more understanding. I will explain actually why they brought the restriction. So for now, let's forget about x is greater than or equals to 0. I want us to sketch this graph of f of x equals to 1 over 4x squared. And again, guys, I'm not answering the question of 6.1. I'm simply saying, let us look at this f of x equals to 1 over 4x squared in terms of a sketch. I'm not answering any question yet, but I want us to look at f of x equals to 1 over 4x squared in terms of sketch. I'm saying, let us sketch this graph, 1 over 4x squared. So let's look at it. 1 over f of x equals to 1 over 4x squared. It's a quadratic graph. We need the x-intercept in order to sketch it. So this quadratic function, its x-intercept actually it's 0. How do we find the x-intercept? We find the x-intercept of a function by letting y to be 0. So if you substitute your f of x with 0, if you say 0 equals to 1 over 4 x squared, and you divide both sides by 1 over 4, you have 0 equals to x squared. So you notice that the x-intercept, it's 0. So this f of x has got the x-intercept of 0. What is its y-intercept? It's important to talk about the x-intercept, y-intercept, because we are sketching a quadratic function. Its y-intercept, this f of x equals to 1 over 4x squared. Its y-intercept, it's 0. Okay, why am I saying its y-intercept is 0? How do we find the y-intercept of a function? We find the y-intercept by letting x to be 0. So f into 0 equals to 1 over 4. My x is 0. So f into 0 is equals to 0. So this function has got the x-intercept of 0. The y-intercept of 0, so we know where it's passing. It is passing at the origin. It is passing at the origin. It passes here at 0 and 0. And because the coefficient of x squared is positive, I'm referring to the 1 over 4 value. This 1 over 4, it's a positive value. So because a is greater than 0, you know that a quadratic function where the value of a is greater than 0 has got a smile shape. That graph is concave up. So the graph is like this. This is my graph of f of x without the restriction. I said forget about this restriction here. Remember, in your question paper, they brought the restriction, x is greater than or equals to 0. I said forget about this a bit. Let us look at the function f of x, where x is greater than 0. meaning on where x are positive values, and also let us look at it where the values of x are negative. So this is the negative side. So we don't restrict our function. This is my graph of f of x. We found the restriction. Now, let us have some few points on the graph of f of x. So we have got the point here, obviously it's 0 and 0 on the origin. Let's say we have a point A here. And let's have another point B. So I want us to have 3 points on the graph of f of x. So let's say the x coordinate of a point A is -2. Let's say the x coordinates of a point A is -2. So it's -2. What is going to be the y coordinate of a point A? So if x is -2, we simply go to the function f of x. Remember, this A is a point on the function f of x. So we go to f of x, we say f into where there is x, we put -2. X squared. So where there is x, we put -2. We notice that f into -2, it's 1. So when x is -2, the y coordinate is 1. So coordinates of A is -2 and 1. So at B, I'm going to say, suppose at B, x is 2. What is the y coordinate there? Go and confirm it. The y coordinate will also be 1. You simply go and substitute 2 on a function. So you've got 3 points, A, B. I will call the origin point C, which is 0 and 0. So this is the graph of f of x. We found the restriction. We are looking at it on the positive values of x and also on the negative values of x. So this quadratic function f of x, we notice that it is one to many function. We call it one to many function. And you guys, grade 12s, you must know what is one to one function and also what is one to many function. So what are we referring to when we talk about one to many function? One to many function is whereby one value of y is sharing different values of x. For example, in this case, 1 can be mapped with x of -2, and also the same 1 can also be mapped with 2. So one value of y is sharing different values of x. So we say this is one to many function. One to many function can be visualized or it can be tested by what we call a horizontal line test. So I'm going to draw this line. I'm calling it a horizontal line test. If this line cuts the graph twice, 1, 2, we say this is one to many function. So this kind of a function, it's one to many function. Now, the examiner here did something interesting. He said, let us restrict the graph. So if we restrict the function f of x, if we only focus on the values of x being greater than 0, so we are focusing only on the positive values of x. So we are going to ignore this part of the graph. Sorry, I erased everything while I was trying to ignore the left part of the graph. I want to be left with this side. You see? The other part of the graph, let me draw it with a different color. I will say ignore the part which is shown with a blue color, because on that side of the graph, all values of x are negative. So the examiner says, look at the graph of f of x only where the x values are positive. So which means now, if we sketch the graph of f of x in this case, we found the restriction, the graph is like this. I want you to guys to get this idea of restriction, because I think it's coming in your final exam. They will bring something which has to do with a restriction. If you look at it without restriction, the graph is like this. This is the graph of f of x. Not the inverse. Don't get me wrong. I'm not answering 6.1. I've not yet started answering 6.1. This is the graph of f of x without restriction. But if we look at it, taking into account the restriction, we are saying focus only where the values of x are positive. The graph now becomes this. We remove this left-hand side. Where x is negative there, we are left with this part. Yes. So this is, remember, I had a point here, it's 0 and 0, and I also shown one point on, I just call it point A, and I noticed that it was 2 and 1. Okay. So this is my graph of f of x. Now the question is, how do I sketch the inverse? Or why do we normally restrict the function? Before I even answer 6.1, why was the function f of x restricted? The function f of x, it is restricted so that it can become one-to-one function. One-to-one function. Now it's one-to-one function, because if we draw a horizontal line test, we see that a horizontal line always touch the graph only at one point. So we say, oh, if we restrict the function f of x, in this case, with the property that x should be greater than 0, the function becomes one-to-one function. But if the graph is not restricted, remember, if it's not restricted, it has got this other part. If it's not restricted, it's one-to-many function. So we restricted it so that it becomes one-to-one function. So one of the questions that they can bring in your exam, remember we are preparing for exam, they can give you a graph like this. They don't give you this restriction. They just say f of x equals to 1 over 4 x squared. And they say to you now, restrict the graph in such a manner that it becomes one-to-one function. So how are you going to restrict it? You see that there are two ways. You can say if the graph, if our x values are greater than 0, we focus only on this side of a graph. Then the function is one-to-one. Or maybe you can say if the values of x are less than zeros. So if we talk about x being less than 0, we will be talking about this left side of the graph. We remove this side. The function will still be one-to-one. But if it's like this, it's one-to-many. So I have a feeling that they can ask you concerning the restriction of a function. They can say restrict a function in such a way that it is one-to-one function. So here, when we go back to our problem of f of x, I'm saying f of x, if we sketch it taking into account the restriction, f of x is like this. So we have got a point 0 and 0, and I just determined one point and I just called it A, and I said it's 2 and 1. Now, to sketch the graph of the inverse, remember this is the graph of f of x, whereby all values of x are greater than or equals to 0. So to sketch the graph of the inverse, I'm now answering 6.1, where they say sketch the graph of the inverse, showing any intercept with the axis and any other point on the graph. So it's going to be easy to sketch the inverse, guys. I'm going to say, okay, if I look at f of x, I have a point 2 and 1. It's 1 point on the graph of f of x. So this implies that the point on the inverse, it's going to be 1 and 2. You simply swap those coordinates. Now another point was 0 and 0. If you swap 0 and 0, it will still be 0 and 0. So now let's show this point on the graph. Let us sketch the inverse. I'm going to do this. Now I want to sketch the inverse. I'm going to have the y-axis. I'm going to have the x-axis. Now I say, I know 1 point on the inverse. It's 1 and 2. When x is 1, y is 2. I have a point on the graph of the inverse of f. It's 1 and 2. Another point, it's 0 and 0. It's here. So what is the graph of the inverse? If I connect all the points, it's going to be like this. So this is the graph of the inverse of f. So, and if you look at this graph, it is 1 to 1. How do I know? A horizontal line test tells me that it's 1 to 1 because the horizontal line test touches the graph of the inverse only at 1 point. So this is 1 to 1 function. And this inverse is a function also because you can use a vertical line. Whenever the vertical line touches your curve at 1 point, we say the curve is a function. And we use a vertical line to test whether the curve is a function or not. So if the curve touch the vertical line once, that curve is a function. If a horizontal line touch the curve once, that curve is 1 to 1 function. Okay, so this is the sketch of the inverse. And guys, please, when they ask you to sketch the inverse of a function, identify the points on the original function. That's the first thing. You say on the function f of x, I have a point 2 and 1. So it means that the point on the inverse is going to be 1 and 2. So please guys. Now 6.2, state the domain of the inverse. Okay, stating the domain is going to be easy. Let us go to the graph of the inverse. The inverse is like this. Remember, I said we have a point 0 and 0, and we have a point 1 and 2. So what is the domain of this inverse? We can see that, remember, when we talk about the domain, we talk about the set of values of x, whereby by the function is defined. So we're going to focus on the values of x. And when we look at the graph, we know that at the origin, the x value is 0. And the graph, it's always on the right side of the y-axis. So we say all values of x are greater than 0. So this is the domain. X is greater than equals to 0. This is 6.2. This is the domain of the inverse because your inverse, it's always on the right side of the y-axis, which tells us that all values of x are positive. We don't have any negative value of x from this function of the inverse. If they had asked you about the range, you were going to say y is greater than equals to 0 because I don't see the negative values of y from the function of the inverse. I don't so the range or because the function also is above the x-axis. The inverse, it's above the x-axis, meaning that all values of y are positive. Whenever the graph is above the x-axis, it means that the values of y that comes from that graph are positive. Okay, 6.3, when the graph of f is shifted. Now let's look at here. Focus inside here. They are saying x plus 3. So what are they doing? They are shifting the graph of f. Okay, now my question is, I wonder if they are shifting to the right or they are shifting to the left. That's one of the questions that we must ask ourselves. How are they shifting the graph of f? They are saying f into, mathematically we are used to functions being written like this, f into x. So but they are saying f into x plus 3. So they are doing something to the x value. You can see they are saying, let's go, they say go to the graph of f, where you see x, you substitute it with x plus 3. We are finding a new function. Okay, let me write. The original function f of x is 1 over 4 x squared. But they are saying go to f, where there is x, substitute x plus 3. Where there is x, substitute x plus 3. Put x plus 3 on the place of x. So what is happening? What are we doing here? Whenever we add to x, we are actually shifting to the left. I think this is a shift to the left by 3 units. You need to know this idea of shift. This is shift to the left by 3 units. Whenever we add to x, we are simply shifting the function to the left by how many units? 3 units. If it was minus 3, it means we were shifting to the right. Whenever we subtract from x, we are shifting to the right. But here they are saying plus. So we are shifting to the left by 3 units. So when the graph of f is shifted to the left by 3 units, f into x plus 3, point A on F. So they are saying we had a point on F. So point A, we had a point on F, which is A. This point A on F is shifted to the point 4 and y on the function which is formed when we shift the original function to the left. So they want the coordinates of the image of a point A. Okay, okay, okay. But this is not challenging at all. Not challenging at all. So I know that I have a point, okay, A on F. I have a point A on the function F. And when this point A is shifted 3 units to the right, it gives us a new point. Remember, this is a function of f of x, and here we have a function of f into x plus 3. So whenever the point A on f is shifted 3 units to the left, I meant to the left, this function is shifting to the left. Whenever we shift the point A 3 units to the left, we get a new point on the function f into x plus 3. I will call it A prime. And they are saying the coordinates of that new point A prime, which is the result of shifting to the left, it is 4 and y. And they want us to find the coordinate of this function, of this point A prime, which is 4 and y. They want us to find the y coordinate. So how are we going to find the y coordinate? Okay, when we shift the function f to the left 3 units, we are forming the new function which is of this nature, which is 1 over 4 x plus 3 squared. Now, I want to know the y coordinate where x is 4. So I will say f into x is 4, x is 4, 7 squared is 49. So I have 49 over 4. So the point, determine the coordinates of the image of a point A. Yes, the A prime. The coordinates of the image of a point A, it's 4 and 49 over 4. Okay. So let's go to question 7. What I like about question 6 and question 7, there is a huge link. They link because it's all about the function and its inverse. In the diagram below, we have got, in the diagram below, f of x is equal to 2 to the exponent x. In the diagram below, f of x is equal to 2 to the exponent x. This is the exponential function. I know it because my variable x is the exponent. Whenever the variable x is the exponent, the function we are dealing with is the exponential function. So I have a function which is what? F of x equals to 2 to the exponent x, which is my exponential function. And the inverse are given. So they've given me the function f. If you look at the diagram, they gave me the function f and also the inverse of f. And also the inverse of f. So I will say this side, this is f of x. Here I have f of x. I will draw table like this. And I say this side, I have the inverse of f of x. Okay? Because they're talking about the function and its inverse. Let me erase. I will present my diagram in a very neat manner. I will do, let me just go. Yes, I will say, let me do this. I will say this side, I have f of x, which is the function itself. And I will say this side, I have f prime to the negative 1, which is the inverse of f. Because they are talking about the function and its inverse. I think we will need to look at these two, the function f of s and its inverse. Now, they are saying A and C are the point on f. B is a point on the inverse. CB and AB are perpendicular to each other. Okay? I wonder what is the first question. Write down the equation of the inverse in the form y equals to. Yes, yes. Okay, so if you look at f of x is equals to 2 to the exponent x. Now, they are looking for the equation of the inverse of f. How do we find the equation of the inverse of a function? The first step, we swap y and x. So this f of x equals to 2 to the exponent x is the same as y equals to 2 to the exponent x. So what you are going to do, at the position of y, you are going to put x. At the position of x, you're going to put y. So this is your first step. X is equals to 2 to the exponent y. So this x equals to 2 to the exponent y is the equation of the inverse of f. But unfortunately, it is in the form where y is not the subject of the formula. And the examiner has been very specific here. He's saying, give us the equation of the inverse in the form y equals to. So I have the equation of the inverse, but in this case is in the form x equals to. So I have to make y the subject of the formula. How? By involving log. So I have x equals to 2 to the exponent y. I want to make y the subject of the formula. What I do, I identify the base first. With me, identify the base. So 2 is the base. Y is the exponent. So next to the base, I put log. So I will say log of the base. And guess what? I'm going to interchange x and y again. Where there is x here, I put y. Where there is y, I put x. So this is the equation of the inverse. Y equals to log x base 2. And it was simple actually to find the equation of the inverse. Remember, we have this, the function is f of x equals to 2 to the exponent x. I've noticed that finding the inverse of f of x here, you can simply just come and say, you know what, let me put log before this 2 to the exponent x. You just come and say log. Then you have the inverse. But I don't like my latter approach. I don't like my last approach. The first approach, it's absolutely correct because it gives you all the necessary information. It tells you what is it that you must do when you are looking for the equation of the inverse. So what we do here, guys, we give you a function f of x, which is equals to 2 to the exponent x, and we ask you to find the inverse of this f of x. So your first step is to swap your y and x. Where there is y, you put x. Where there is x, you put y. Then you make y the subject of the formula by involving log. So you go to the base, you say log, you put just near to the base there, you put log, you swap where there is y, where at the position of y, you put x, at the position of x, you put y. So y equals to log x base 2 is the equation of the inverse. Okay. Now they say calculate the length of AB. Calculate the length of AB. So let me look at A. Okay, find the distance from A to B. So what is looking for? The length of AB. It will be a good idea to have the coordinates of A and also the coordinates of B. If we can have the coordinates of A and the coordinates of B, it will be easy to find the length of AB. So, but we see that the y coordinate there at A, it's free. Okay, this is interesting. This is so very interesting. I want you guys to see what's happening here. They are saying this line, okay, this line, it is perpendicular to the y-axis. The line that is perpendicular to the y-axis, it's parallel to the x-axis. Remember, we know that the y-axis is actually perpendicular to the x-axis. If you did not know, the angle here is 90 degrees. The y-axis, it's always perpendicular to the x-axis. Now this guy is saying the y-axis is perpendicular to this line, the dotted line which I've shown with a red color. So if these two lines are perpendicular, if this y-axis is perpendicular to this line here, it means the line drawn with a red color is also parallel to the x-axis. Y-axis is perpendicular to the x-axis. Now, because y-axis is perpendicular to this line of AB, it means this line that passed through AB is parallel to the x-axis. So, and if these two lines are parallel, if this line is parallel to this line, it means this line is a horizontal line. because the x-axis is a horizontal line. So it means this line is a horizontal line. Now, just because the line is horizontal, it means the y coordinate will not change along the horizontal line. So it means at A, I might not know x, but y is free. At B, I might not know x, but y is free. So along the horizontal line, the y coordinate does not change. So the y coordinates will always be free along this line. Red, I've drawn the line with a red color. Okay, so I know that at A, y is free, at B, y is free. So I will try to find the x coordinate at A and also the x coordinate at B. Maybe I was supposed to say x1 at A and x2 at B, just to indicate that the x value at A is different to the x value at B. So now let me see, okay, the function f of x, the function f of x pass through the point A. So it will be easy to find the coordinates of a point A. Remember, this is f of x. So f of x, which is equals to 2 to the exponent x, is passing through the point A, where the point A, at the point A, the y coordinate is free. So I will say free is equals to 2 to the exponent x. Now I have to solve for x by making x the subject of the formula by involving log. So this is 2 to the exponent x equals to 3, which is the same as 3 equals to 2 to the exponent x. Okay, let me just keep it this way. I said identify the base. Your base is what? Is 2. So next to the base or just before the base, put log. Say log. You write the base. What you do, you interchange the position of 3 and x. Where there is 3, put x. Where there is x, put 3. So x is equals to log 3 base 2. And then what are the coordinates of B? B is a point on the inverse of f. So remember, the function f is this one, y equals to 2 to the exponent x. This is the function f, y equals to 2 to the exponent x, or you can say f of x equals to 2 to the exponent x. So the equation of the inverse is going to be x equals to 2 to the exponent y. Remember the inverse, we simply interchange y and x. Now I know y there at B, it's free. So I have a right to say x equals to 2, substitute y with 3. So x equals to 8. So at B, x is 8. So B, the coordinates of B, it's 8 and 3. The coordinates of A, remember the x coordinates there is log 3 base 2. So it's log 3 base 2. Log 3 base 2. So let me write it in terms of the coordinates of A, log 3 base 2 and 3. So to find the distance from A to B, don't even involve the y coordinate. Don't use the distance formula because you are looking for the distance of a horizontal line which is parallel to the x-axis. To find the distance of a horizontal line, you can say x at B minus x at A. You just take x at B, which is 8. You subtract x at A, which is log 3 base 2. Yes, it's 8 minus log 3 base 2. Okay, so let me check what was the question. Calculate the length of AB. 5 marks. I'm getting 8 minus log 3 base 2. I wonder how can we simplify it further, but it is indeed the length of AB is 8 minus log 3 base 2. Because I tried to find the coordinates of A and also find the coordinates of B and then say x at B minus x at A. So I wonder if there is a different approach. Maybe, okay, let me see. Maybe if I take, um, I want to check if I can do something because 8 minus log, I'm concerned about this guy here actually, even though I'm quite sure that that is correct. So I wonder if we can simplify 8 minus log 3 base 2, if it can be simplified further. So let me check if there is any approach that we can take to find the distance between the point A and B. So what matters most is to take x at A, is to take x at B and subtract x at A. And A is on the function f, where f is equals to 2 to the exponent x. And we know that, or maybe I don't see that value carefully. Maybe it's 8. Is this value 8? Or if it was 8, it was going to make more sense. I wish this value was 8, but it appears to be 3. It's 3, right? Oh yeah, it's 3. But guys, I think the approach is correct. You just have to find x at A and also find x at B, and you take x at B, you subtract x at A. This is how you find the length of a horizontal line. And remember, the length should not be negative. The distance can never be negative. So you take x at B and you subtract x at A. So this key idea, you need to remember it. How do we find the distance of a vertical line? If we've got 2 points A and B, you take y at A, you subtract y at B. If we have a horizontal line, we have a point A and B. To find the distance, we take x at B, we subtract x at A. So that is the key idea there. So calculate the length of CB, where CB is perpendicular to AB. So let us go to CB. They say CB is perpendicular to AB. He's simply saying this line CB is parallel to the y-axis. He's simply saying the line CB is parallel to the y-axis, because we already know that AB is perpendicular to the y-axis. Remember, AB is perpendicular to the y-axis. Now the guy say CB also it's perpendicular to AB. This means that these ones now, they are parallel. Y-axis and CB are parallel. So because CB is parallel to the y-axis, which we know that is a vertical line, it means that also CB is a vertical line. Now, because CB is a vertical line, to find the distance from C to B, we have to take y at C and subtract y at B. Y at the top minus y at the bottom. We don't even have to use distance formula. We just have to find the y coordinate at C and the y coordinate at B. And guys, remember we did find the coordinates of B. We found the coordinates of B. What was the coordinates of B? Remember this f prime negative 1, did I say prime? F to the exponent negative 1 is the inverse of f, which is represented by this equation. X equals to 2 to the exponent y, and also y equals to log x base 2. Both these two represent the inverse of f. It's just normally this is where y is the subject of the formula. But also this x equals to 2 to the exponent y is the inverse of f. So I used this x equals to 2 to the exponent y to find the coordinates of b, because I know that at b, y it's free. So x equals to 8. Okay? At b, x is 8, y it's free. So it means that at C also, the x coordinate, it is 8. Remember that the x coordinate along the vertical line does not change. So if x at B, it's 8. Even x at C, it's also 8. So I have to come back to this function f, which is f equals to 2 to the exponent x, and say because I know the value of x at C, it's 8. What is the value of y? It's 2 to the exponent 8. Okay, the value of y, I will just say 2 to the exponent 8. You will press it on your calculator. It will tell you how much is 2 to the exponent 8. And then you now take y at C, which is 2 to the exponent 8. You subtract y at B, which is 3. You found the distance of a vertical line CB or BC. Remember, the distance should never be negative. So the distance from B to C actually is 2 to the exponent 8 minus 3. Write down the domain of the inverse of f. It's our last question. Oh, this is a very interesting question. You know, if you spend time talking, by the time you get tired of talking, you end up rushing. So I have to be careful of that. Because I've been talking, I have to be careful that I don't rush the information. So now they are saying, give us the domain of the inverse of f. Okay. Makes sense? Let me see. It's a very interesting question. I will do this. If you look at the function f of x, represented by the equation 2 to the exponent x, which has the inverse, surely it has an inverse. This function f of x equals to 2 to the exponent x, it has an asymptote. This is an exponential function. The exponential function, it has got only the y asymptote. And in this case, the y asymptote of f of x is 0, which is represented by the equation y equals to 0. So if the function f of x was something like this, f of x equals to 2 to the exponent x plus 1. Our asymptote, the y asymptote, was going to be this number at the end. So the equation of the y asymptote was going to be y equals to 1. So f of x equals to 2 to the exponent x. It has got the exponential function. Please, 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 guys. The exponential function has got the y asymptote, but it's inverse. Its inverse, it has a horizontal asymptote. So if the function had the y asymptote of 0, it means it will have the x asymptote of 0. If it had the y asymptote of 1, its inverse will have the x asymptote of 1. So you need to be careful. Now the f of x has the y asymptote of 0, so its inverse should have the x asymptote of 0. And if we show this asymptote of the graph, x equals to 0, is this line which is found on the y-axis, which means that this inverse can never touch this asymptote line. So the domain of our graph is x, it's always greater than 0. And don't include equal sign. Don't say x is greater equals to 0. No, 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 no. The graph, the inverse cannot touch this vertical line of x equals to 0. So we say all values of x ought to be greater than 0. That was one of the great questions that they brought. So be careful. The y asymptote of a function will be the x asymptote of the inverse of a function. Now we go to calculus. I will deal with a calculus separately. I'm stopping the meeting.